This inequalities lesson is kind of a weird thing to go in this chapter, but the reason is most of the inequalities that we're going to be solving are polynomials, going to involve polynomials or rational functions, which we've been working a lot with. So it's kind of a natural fit at the end here. Plus, we just talked about solving equations, right? So, all right, so we've done the thing where like I make up examples and we go over examples that I pick, and then we've done the thing where the book, like we just use homework problems out of the book to do examples. Today, we're going to flip it around and you guys are going to make up the examples. So I'm going to kind of get the basics of it started. I'm going to write a function and I'm going to make some of these decisions for us, but I'm going to have you guys give me some input. My function is going to consist of 4 factors. Is this going to be a polynomial or a rational function, do you think? Polynomial question? Let's talk about that in a second. Yeah, I think we will put some irrational zeros in there. But someone give me some nice simple linear factors. Give me a nice little linear factor for this one. What do you want? X plus 8. That's a great one. Give me another linear factor. Who else got a linear factor for me? Just shout it out. How about something with a minus in it? X minus 1. Like it. How about one more? One more nice linear factor. Plus, minus, doesn't matter. X minus 2. Great choices, all of those. Someone give me one more with a plus in it. One more with a plus. And I'm going to change it. I'm going to mostly do what you tell me. Look, what do you want? X plus 7. Except I'm going to make it X squared plus 7. And one other thing, I want one of these factors to be squared. So we end up with the multiplicity of 2 on one of our zeros. Which one should we square? The X minus 1? All right, let's square this. That's a great example you guys made. Very nice, very nice. All right, so let's talk zeros. We're going to have a 0 from that first factor. X plus 8, we know by now that's going to give us a negative 8 for 0. X minus 1, that's going to give us a positive 1 for 0, multiplicity 2. X minus 2 is going to give us positive 2 for a 0. What about x squared plus 7? Yeah, if we set x squared plus 7 equal to 0 and solve that, I think we're going to get imaginary answers, aren't we? Yeah, plus or minus square root of negative 7. And when we're doing, here's the good news, when we're dealing with inequalities, we don't need to worry about those. So I'm just gonna go ahead and write for this, I'm gonna write that we have 2 complex zeros. The nice thing is we only have to worry about the zeros that we can graph, and we can't graph complex zeros. So good news. Okay. So we're going to make a sign graph now. And you want this to probably take pretty much the entire width of your paper, because we got a lot of information to squeeze in. So leave a little bit of space here. Draw me a number line. Nice big long number line. And let's label negative infinity and infinity. So of our zeros, we have 3 of those zeros that we can graph. So I'm going to just kind of evenly space it out. So I've got 3 tick marks on there, relatively evenly. I don't really care about getting everything like the correct distance apart. I just want to get them in there. We want to put them in numerical order, which, wow, I think we already did that. Impressive. Negative 8 would be the furthest to the left, and then 1 and then 2. So obviously this is not to scale, but that's okay. And then I'm gonna split up my space up here. I like to draw little dashed lines. That's just kind of style. Is this looking familiar? Have you seen this before? Oh, I need a helper. Can somebody be a helper for me? I'm gonna pass this stuff out. Who wants to get up and move around? Spaghetti, yeah. Please. Come on now. Can you give everybody just like that big a piece of spaghetti? Got him? Yep. All right. Sam is gonna give you a roll. All right. While she's doing that, we're gonna do one other quick step here. So what I'm gonna do is I'm going to copy the format of my factors here without anything inside of the parentheses. So I'm gonna just draw 4 parentheses, and the second one's gonna be squared. We don't worry about anything that's inside the parentheses. We're just gonna draw them and put any exponents on them. And those go in all 4 of these regions. This is the reason I told you to kind of make it nice and wide. Is this starting to look familiar? All right. Let's do a little color coding here. If you have colored pencils, you might appreciate that. Thank you. All right, so here's what we're going to do. We need to go through each of our regions here. We've got 4 regions. Thank you. And we need to pick a test point in each region. So I need to pick a test point in this region. So someone come up with a value between negative infinity and negative 8. What do you want to use? Negative 10. Up here, I'm going to write x equals negative 10. That's my test point. And what I'm going to do is I'm going to take negative 10, and I'm going to go through and plug it into each of these factors. Actually, no, backtrack that a little bit. Let's pick some more test points before we do it. Do we want to do it that? How do I want to do this? I want to give you guys this shortcut. Can we jump straight to the shortcut this time? Usually I like to do kind of the mathy thing and then the shortcut at the end. Let's do it a little bit differently, okay? So let's do this. Instead of going region by region, let's go factor by factor. All right. So my whole goal is inside these parentheses, I want to write pluses and minuses. If this factor ends up being positive in this region, I want to write a plus. If it ends up being negative in this region, I want to write a minus. So think about in this region, if I were to plug something between negative infinity and negative 8 into this first factor, is that going to give me a negative answer or a positive answer? If I had put negative 10 in there, that would give us a negative, right? So this is going to be a minus. And it wouldn't matter what test value I picked in here. That's why I'm kind of skipping the test value piece, right? If I put negative 1000 in here, would you agree it'd still be negative? If I put negative 8.1 in there, would you agree it would still be negative? Now there's a shortcut to this, and this is what our spaghetti is for, okay? I want you to think about x here, and I want you to think, what's the special value for this factor? The special value for this factor is what? The 0 of this factor is negative 8. Can you put your little spaghetti wall up across 8? I want you to think about what happens to this factor when we put in numbers that are less than negative 8, and what happens when we put in numbers that are bigger than negative 8. We already talked about when we put in numbers that are less than negative 8, that came out negative, right? Would you agree that if I put anything greater than negative 8 into this factor, that factor will be positive? So this factor is going to be positive for all of those factors. All the ones to the right of my spaghetti wall are going to be positive because any number bigger than negative 8 is going to make this positive. Agreed? All right. I'm going to skip the next factor and move on to the x minus 2. Focus your attention on this x minus 2. This would be our third factor. Put your spaghetti wall up at the 0 for x minus 2. The 0 for x minus 2 is 2. Put your spaghetti wall up at 2. Now think through this with me. If I have a value that's less than 2, that would be any place to the left of my wall here. What kind of sign am I going to get out of this? Positive or negative? Agreed? If I pick anything less than 2, that this factor is going to be negative. All right, so these are going to be negative over here. This is our third factor. Left of the spaghetti wall gives us negative factors for x minus 2. And if I pick a number that's bigger than 2, what are we going to get out of this? Positive. So all of my regions to the right of the spaghetti wall, there's only one, are going to get a plus. Okay? You see how this works? This is much faster than picking test points. Otherwise, you got to pick a test point and you got to go through and do 1, 2, 3, 4. You end up doing 16 different problems. This way, we only have to do like 4. We've done okay so far. We'll practice the spaghetti wall again in a little bit. There's something special about this factor, the x minus 1 quantity squared. What's going to be special about that one? Because it's squared, it's always going to be positive, right? Because I'm squaring this, this is going to be positive. So this whole thing will be positive. So I don't need to worry about whether it's positive or negative on the inside. I know that it's always going to be positive. That second factor is always going to be positive. The inside of it might be negative, but the overall thing is going to be positive. That's what I'm trying to show there, correct? All right, and there's something special about our last factor as well. What's special about x squared plus 7? It has complex zeros. We don't need to worry about spaghetti wall for this one, though, because if I square x, I'm going to get a positive number or 0, right? And if I add 7, it's going to stay positive, right? It has to be positive. Agreed? There's no way that can come out negative. So these are all going to be positive. You know what? I'm going to erase these squares because that just looks like a plus 2. Doesn't that make it look like a plus 2? Not like this part. Erase the square and put the plus 2. All right, so the whole purpose of this is to determine what is the overall sign for each of these regions. So I am multiplying 4 numbers together in this region. 2 of them are negative and 2 of them are positive. What is my final answer going to be, positive or negative? Negative or positive? Positive or is it negative? What's a quick shortcut for determining if it's negative or positive? Yeah, look at, there's 2 negative numbers, right? What happens when you multiply a negative times a negative? You get a positive, and then you multiply it by a couple more positives, and it stays positive. Agreed? So shortcut is what? Oh, you had a question. Okay, we'll come back. What's the shortcut? Look for the number of negatives, and if it's even number of negatives, they're basically going to cancel each other out, right? If you got an odd number of negatives, you'll still have one left over. So this one's going to be positive altogether because a negative times a positive times a negative times a positive will give you a positive answer. What about this region? I'm multiplying 3 positives and a negative together. Final answer there will be negative. Final answer here. Oops, I forgot my plus in that spot. 3 positives and a negative. Negative. Final answer here, a whole bunch of positives. Gonna give me a plus. Okay, coming back to your question. Thanks for your patience. Oh, I answered it. Okay. What was it? Just in case somebody else was thinking the same thing. Exactly that. Yes, I'm just multiplying all those signs together. But there is a little bit of a shortcut. If you look anytime you see a pair of negatives, those are going to cancel each other out, right? And make a positive. All right. Is this looking familiar? Have you seen this before? So basically what we've done is we've shown that in this region, our function is going to be positive, greater than 0, right? In this region, our function is going to be negative, less than 0, and greater than 0. And what's going to happen at -8 and at 1 and at 2? What is our function equal to at those 3 places? It's equal to 0. Let's go ahead and write that in. It's equal to 0 at those places. If I wanted to make a rough sketch of what this graph looked like, I would expect to see some x-intercepts. It's going to be positive over here, right? So it's going to be above 0. And then at -8, it should be hitting 0. And then between -8 and 1, it should be negative. So it should be down below. And then it's got to come back up and hit 0 at 1, right? Because it's equal to 0 there. And then it's down below again between 1 and 2. Then it comes back to 0 at 2, and then it ends up positive over here. It's going to look something like that, roughly. But the main thing we want from this is to be able to solve some inequalities. So I want to know what would happen if I asked you to solve the inequality x plus 8 times x minus 1 squared times x minus 2 times x squared plus 7 is greater than or equal to 0. What would my solution be? So we analyzed it as a function, but really the whole goal here is to solve inequalities. All right, so greater than or equal to 0. Are we looking for positive regions or negative regions here? Positive regions, right? Greater than or equal to 0 would be positive regions. So we're looking for positive regions. All right, and I see 2 of them. I'll write down the first one, see if you can write down the second one. My first one is from -infinity to -8. And infinities always get parentheses. What about that -8? Do we want a bracket or a parenthesis around that -8? Bracket or parenthesis. We're looking for greater than or equal to 0. And it does equal 0 at -8, so we would include that. So square bracket there. See if you can find me my other region that would be part of our solution. Remember, we're looking for positive regions. There's one other positive regions. One of them was from -infinity to -8. That was positive. My other one is over here. Did you do a square bracket around the 2? Parenthesis around the infinity? That's our solution. Hey, and there's some let me show you this fancy notation. Since these are regions, we don't say x equals these regions, we say x is a part of these. It's kind of like it's almost like a C with a little line in it. I don't know what the name for this character is. I'm sure it's Greek. But it means x belongs to those regions, or x is in those regions. Yes?
Because it's equal to 0 as well, we put 1.
Ooh, good call. I messed that up. I missed something. There is one other place where it's equal to 0. At 1, it's equal to 0. Thank you for that. I'm going to squeeze that in. This is a style thing, but I want you to get into good habits. When we do interval notation, we always don't want to go from left to right, which is easy to do if we have a number line. So agreed, it is equal to 0 at 1. This is less than or equal to 0. Thank you. So remember, if you have a single value like 1, it's not a region, it's just a single value. That goes in those sideways mustache things. I think those are called braces, maybe. All right. How would our solution change if it had been, now instead of copying all of this down, I'm just gonna write f of x, okay? I don't want to write all that down again. If you want to, you're welcome to. If I wrote all that down again, which was f of x, right? And I asked you to find the regions where it's strictly greater than 0, how would that change your solution? If it was strictly greater than, so not greater than or equal to anymore, but strictly greater than, what's going to change about our solution? Yep. Brackets will change to parentheses, and then we're going to lose the 1, right? So it'd be the same thing. It's just -8 is no longer included because that's equal to 0. We're not interested in equal to 0 this time. And then 2 to infinity. I'm going to challenge you to find me solutions for f of x is less than or equal to 0 and f of x is strictly less than 0. See what you can do with those two. Remember, if we're talking less than 0, we're looking for negative. Wow, we got a super long class today. This is awesome. All right, so I'm looking for negative regions. There. Ooh, this is a little tricky. So this time we're looking for where our overall solution is negative. So go ahead and check your answers against mine if you got answers. If you're not sure, go ahead and have a look at mine, see if you can figure out where I got those numbers from, and let me know if you have questions. I put 2 different versions of the answer for this one. I would say, which one would you think is, they're both technically right. Which one's better? The one on the left is better. It's more concise. It really gets at the point of it. Do you see why I don't need to really worry about the 1 here? If I'm looking for places where it's less than or equal to 0, I'm looking for negatives or equal to 0, right? It's equal to 0 at -8, and it stays either negative or equal to 0 straight on through to 2. There's no breaks in that solution, so there's no need to split it up into 2 different sets. We can just say -8 to 2 and call it a day. So this would be the better answer. This, for this test, I wouldn't count you off points or something like this. Second semester, maybe. Okay. But we do have to break it up for strictly less than 0 because that would not include the equal to 0 that's happening here at 1, right? All right. You guys show me on your thumb how you're feeling about this right now. This has been a long week and everybody's a little like lethargic and tired, so I'm having a hard time reading. Okay, so it looks like we're in the learning phase, right? Somewhere between sideways and up. Okay. All right, let's do one more then. Oh, you know what we need to do before that though? Sorry. Your homework's going to ask you to verify graphically. You can actually solve these things graphically. In fact, there's a portion of your homework that tells you to solve it graphically. So let's break out our calculators and make sure we're comfortable with this. So if it tells you to solve graphically, you don't have to do nearly as much work. So make sure you're reading your instructions. We're just going to plug it in and look at the graph. And we'll look for parts of the graph where it's bigger than 0, above 0, or above the x-axis, and where it's below. So, a second to type this in. And 6. Oh, I hate when this happens. Get a whole bunch of vertical lines and stuff. Ew. It's kind of hard to tell where it's like above and below when you have those lines that look almost vertical, doesn't it? So there's a couple of fixes for this. I could go into my window and set my y min and my y max to be bigger numbers. The other thing that I could do is I could go back into my function and give it an a value. I'm going to put it at the end instead of the beginning, but just multiply it by, if I want to kind of shrink it down vertically, what do I want to multiply it by? Something low, like 0. Let's try 0.1. That might be too small. So we get that. Yeah, well, it's a little bit better. I can kind of tell that it's going to be down over here, which means it must be up over here. So comparing this to our answer for this inequality, where it was greater than or equal to 0, I can look at my graph and say, okay, it's greater than or equal to 0 over here. It's bigger over here. So to the left of -8. So negative infinity to -8. Boom, boom, right? I can see it's equal to 0 right here at 1. I can see that it ends up being back above 0 from 2 out to infinity. So when you get to the homework problems and they ask you to solve graphically, you don't even have to do sign charts. Okay. Questions? There's a much faster way to do this, but it's kind of advanced. Is anybody interested in seeing that? I'm gonna show you. I'll show you for those that are interested. And if this is like, that's a little too much for me right now, then just ignore me. I'm gonna show you this real quickly. Here's how you would do this. If you wanted to, you could look at this and figure out what would my lead term be if I were to multiply all this out and actually turn it into a standard form polynomial. What would I have as my lead term? X to the 6th, agreed? X, and then X times X because of the squared, right? So X, 1, 2, 3, 4, 5, 6, agreed? We'd have X to the 6th plus a bunch of stuff. Okay. That's enough information for me to determine the end behavior for this graph. And I'm just gonna do it graphically. If it's X to the 6th, it's positive, it's an even power. What's that end behavior look like? Even power means they're going in the same direction, right? Positive means they're both up. So my end behavior is going to be up on the left and up on the right. Agreed? All right, so I could, when I make my sign graph, I already know that this is going to be plus and this is going to be plus because that's my end behavior. Those are the ends of the graph, right? Cheat code for finding your two outer ones, right? If we're heading for positive infinity on the far left and the far right, then we got to be positive on both of those. And wait, we can figure out the inside even, and I bet you figured it out, right? So what's going to happen at -8? Am I going to have a sign change or not? Is my graph going to cross the x-axis or bounce off the x-axis at -8? It's going to cross, right? Because that was a multiplicity 1. So if we're going to cross, then we should have a sign change. So it's going to change from a positive. It's going to cross the x-axis. It's going to become negative here. What's going to happen at negative or at positive 1? Am I going to cross the x-axis or bounce off? I'm going to bounce off because it's squared, right? So there's not going to be a sign change there. So there's no change here. So if this was minus and it bounces off, it's going to stay minus. And then boom, I got my sign chart without even plugging any numbers. Then we don't get to use the spaghetti wall. The spaghetti wall is awesome. So it's kind of a win-lose situation. Yes, you can do that. I want to see your end behavior. I want you to write your first term. So write it out, your first term plus dot, dot, dot. Show me what your end behavior looks like, and then sign change, no change. We could also look at this just to verify x minus 2. That's a singleton, right? Power of 1. So sign change there also. You can do it that way if you want. It's a little bit trickier when we deal with rational functions, but it does work with rational functions also. We're going to do a rational example now. We're going to use the spaghetti wall because I like the spaghetti wall. All right, so same thing. We're going to make a new function. Let's call it g of x. And it's going to be a rational function. And I'm going to say let's do 2 factors on the top and 2 on the bottom. And let's keep them all nice, rational zeros this time. So shout it out. Someone give me a factor for the top. Who do we want? X plus 4 on the top. Give me another one on the top that would give me not an integer, but a rational 0. What do you want? 2x minus 5. Good one. All right, how about just a couple just normal vanilla factors for the bottom? Give me one. Another x plus 4? You want to put a hole in here? Okay, are we up for that? Yeah, it does. All right. We want to do that for a first example. I'll tell you what. We're going to do something else, and then we'll come back and we'll change it, okay? Can you give me one that's not going to give us a hole? Let's keep it simple for our first one. X minus 7. And one more. X plus 3. All right, here we go. That's a beautiful function. Let's go ahead and draw our number line. And let's get all of our important values on here. Now, there should be 4 this time. Which means we actually have 5 regions. I did not split those up very evenly. We got to use all the zeros of the numerator and the denominator. Those are going to give us our important numbers. So what's the smallest one that we're going to be dealing with? What's furthest to the left? I think that would be the -4, right? We're going to have zeros at -4 at positive 5/2, which would be 2.5. And positive 7. We're going to have an asymptote at 7 and at -3. So -4 is going to be my smallest. And then -3, and then 2.5, that's 5/2. And then 7, positive 7. And this part's pretty important. Once we get those down and we get them numerically in order, we want to make a note of which ones are going to be equal to 0 and which ones are going to be undefined for our functions. So -4 for our function, is that a 0 or is that going to be undefined? Is that an asymptote? That came from the top, so that's a 0. So it's equal to 0. Our function is equal to 0, -4. What about a -3? At -3, our function is error, right? Undefined, because that's a vertical asymptote. So undefined. 5/2 came from this one. That's in the top, so that's a 0. So we're equal to 0 there. 7 came from the bottom. That's a vertical asymptote. At that point, our function will be undefined. So I know right now that when I go to start writing my intervals, I'm always going to have, if I have a -3 or a 7, they're going to have parentheses. -3 or 7 are not part of this function. They can't go in for x. All right, so let's split our region up into these. Oh my gosh, 5 different points. Oh man, it's a lot. And we're going to need for each of these 2 signs on the top and 2 on the bottom. I'm going spaghetti wall for this one. Let's go factor by factor instead of region by region. So focus with me right now on x plus 4. The special value for x plus 4 is what? The 0 is -4. Put your pasta wall up, put your spaghetti wall up at -4. And think about what happens to x plus 4 when we put in numbers that are smaller to the left, and what happens when we put in numbers that are bigger to the right. When I put in something less than -4, what am I going to get from x plus 4? And if it helps you think of an example, -10. If you put -10 in here, you're going to get a positive or a negative answer. Negative, right? So any factor to the left, any region to the left of my wall is going to get a negative for it, the x plus 4. Now, if I pick something bigger than if I pick something bigger than -4, what's this factor going to give me then? Positive or negative? If I pick something a little bit bigger than -4, this should always be positive, right? So all of these regions over here that are bigger than my pasta wall are going to get a positive for that factor. Yep. Oh, you didn't get a piece of spaghetti? I'm sorry. You'll have to. Oh, you did. Got it. Okay. Thanks. I stole this from a student a couple of years ago. Actually, they used a little paper clip that they bent up, but I didn't. I was like, I got a bunch of pasta. That'll work. All right. My next factor on the top, we got 2x minus 5. My special number there was positive 5/2. So the whole idea of the pasta wall is that these 3 are going to be the same sign, right? Anything that's less than 5/2 is going to always give me the same sign. I just have to figure out if it's going to be positive or negative. And don't think that just because it's to the left, it's always going to be negative, because to the right, it's always positive, because sometimes that flips on you. So do check. So think of a number that's less than 5/2, less than 2.5. Any number less than 2.5. How about 0? 0 is a great number to pick, right? If you plug 0 in for x here, you're going to get a positive or negative answer. Negative. And if that's true, then every number to the left of 5/2 is going to give me a negative. So these are all going to be negatives. And if I pick a number that's bigger than 5/2, like 3, if I plugged in 3 here, positive or negative? Positive. So all of those regions over here are going to get positives for that. The whole idea of the pasta wall is if you put it there, you can kind of do all of the regions to the left, all the regions to the right, kind of all at the same time. All right, pasta wall for x minus 7 is going to go at 7. Think to yourself, what happens when I have values less than 7? That's definitely going to be negative. If x comes in less than 7, then this is going to be negative. So all of these regions that are less than 7 are going to get a negative for that factor. And finally, x plus 3. Put your spaghetti wall up at -3. Think about what happens if I have numbers that are less than -3. I'm less than -3, like -5 or -7. That's going to end up negative. So these will both be negative over here. I'm thinking probably pluses over here, but I'll go ahead and plug in a value greater than -3 and try it. 0 is greater than -3. 0 plus 3 is positives. Yeah, so these are all going to be positives. And somehow I missed this one. So I'll think of a test point. I don't know why I missed that one. My test point is 1,000,000. If I plug 1,000,000 into this factor, that's definitely positive. Okay, so that's cool. Now we just have to figure out where are we positive and where are we negative overall. So any questions about how we filled in the individual pieces? All right, positives and negatives. Remember, if you have any combination of pairs of negatives, they'll cancel each other out. So these will turn into a positive, these will turn into a positive. I think we're going to have an overall positive in that region. I got a couple negatives that'll cancel there. Positive divided by a negative is going to give me a negative in that region. A couple negatives canceling there will leave me a positive. Nothing to cancel this negative, so it's going to be a negative. Whole bunch of positives. So this looks like kind of a long, tedious process. We're talking through it, right? So it goes a little bit faster once you've done it a couple times. All right. So if I were to ask you to, by the way, your problems are never going to look like this. They're going to look like that. That's what your problems are going to look like. Okay. It's not going to say f of x equals something. It's going to say something is greater than or equal to 0 or less than 0 or something like that. Okay. So we kind of set it up as a function. We graph this as a function. Now we're going to see what happens if this function is greater than 0, greater than or equal to 0, less than, and less than or equal to. So what would be your solution? Let's practice this again. If our function were greater than or equal to 0, if our function were strictly greater than 0, less than or equal to 0, and strictly less than 0. See if you can write intervals for those for me. And don't forget, anytime you see a -3 or a 7 in your intervals, those better get parentheses because our function is undefined for those. So see if you can write me solutions for these. Do as much as you can on your own and then check them against mine. Ooh, almost. thinking about here, the whole one, what's going to be different if there's a whole? So if we did have one that was a whole, we would have to, first of all, it would be undefined at that point. So if we had had that, you would ask for x minus 4 in the bottom also, right? Or x plus 4. Yeah. So if that were the case, then this wouldn't be equal to 0, it would be undefined. So we would never include it. Other than that, I think it's going to be pretty much the same process. It would actually be a little bit quicker because when you took care of the one factor on top, you would be automatically, like we had to do 4 separate things, but since 2 of them would match, we wouldn't have to do as much work if that were a whole. I think the only thing that would get tricky if it were a whole is if you were trying to do this using that end behavior kind of advanced technique that I showed a minute ago. It's hard to tell whether a whole is going to give you a sign change or not. Sometimes it will and sometimes it won't. If the whole ends up on the x-axis, it will give you a sign change, but otherwise it won't give you a sign change. So you would have to know where the y coordinate of the whole was. So that would make doing this kind of using that other method a little bit trickier. Does anybody have any questions about my solutions here or corrections to my solutions? Did I make any mistakes there? The dangerous thing about having you guys pick these examples is I don't have them worked out ahead of time. So I didn't have a chance to plug this into Wolfram Alpha and make sure that it was correct. So if you see me make a mistake, that's all right. I mean, mistakes happen, but please let me know so that I'm not showing you the wrong thing. These get a little bit trickier to do with the whole sign change thing like I was talking about, but it is possible. How would I do this? If I wanted to do this in analysis mode, so this is considerably more advanced than what we just talked about here, but I'll show you it is possible. Personally, I would probably stay away from it, especially on a tester quiz. Polynomials, not such a big deal because we know about end behavior there. The end behavior for this gets tricky though, doesn't it? If I were to think about this function, I know that the lead term on the top would be a 2x squared. The lead term on the bottom would be an x squared. So to talk about end behavior for a rational function, you have to talk about its end behavior asymptotes. So I would know by looking at this that since we're balanced, that my end behavior asymptote would be y equals, and it would be whatever my lead coefficient over lead coefficient is. So it'd be y equals 2. So that is enough for me in this case to know that I'm going to be on the far left and the far right, whatever my 2 far left and right regions were. Hang on, let me copy my number line down. So those were our important points. On the far left and the far right, since this is positive 2, then that is going to be positive here and here. Then I have to go through and think about what's going on. This is a multiplicity 1, so we're going to cross. So there should be a sign change here. At -3, so that's a singleton also. So remember with our single asymptotes, you're going to have one arm up, one arm down, which means sign change there also. Here, that's single, so change there. Actually, looks like we're going to change it, all of them. Can't spell today. So we go from a plus, change to a minus, change back to a plus, change to a minus, change back to a plus. That matches what we're looking for. So it can be done. Now, if you end up with it's bottom heavy, then it gets tricky because you're not going to know these, right? Because if it's bottom heavy, it's tending towards 0. We don't know if it's tending towards 0 from above or below. In that case, you might look at figure out what the y-intercept is going to be. That would tell you, for example, what it would be in this region, and you can work your way out to the ends. So it is possible to do this kind of more advanced thing with rational functions, but I would probably default to this if it were me. All right, do you guys have any questions? So the whole idea of a sign chart is you take your factors and you just figure out, I don't care what the values of those factors are. All I care is whether it's positive or negative. And once I know that, I can figure out what my overall sign is going to be, whether it's going to be positive or negative. All right, that's what I got for you guys for today. Your homework is on Canvas, but I'll copy it down here for me just a moment. Page 264, 1 to 19 odd, 33 to 43 odd. Make sure you read the instructions. You're not solving equations in all of these. And some of them, all you're doing is looking at a graph. Which is great because some of them aren't factored. Now there is one that's not factored that you're going to have to, that they ask you to do a sign chart for. In that case, you're going to need to factor it. And you know how to factor polynomials, thank goodness. You'll have to use your graph to get started on it, but you can do it. I believe in you. All right, you got some time here. Get after that. Our class ends a little later than normal today because of the weird schedule. Just plan it out here. But no, 24, I think. Third period ends at 12:24. So we got, hey, like 14 minutes. Let's use it. This is 2.8. Yes. Can I say 2.7 at the beginning? It might have. Not bad. That's 2.8.